thumbs up. And so I'm happy to introduce Matthias Jut to you and the qaul messenger resilient communication during blackouts and internet shutdowns. And I give the stage to you, Matthias.
Thank you. Welcome, everybody. In 2011, we started the project qaulnet, mainly because this has happened before in 2009. It was called the Green Revolution in Iran, and it was called also the first social media revolution. Because thousands of Twitter users just colored their Twitter profile in green. And when Al Jazeera later then made a survey over who was really kind of using Twitter within Iran, there were, I think, about 60 accounts, and all those other people were outside. So what is such a social media revolution? In 2011, the Arab Spring started, and it was called again a social media revolution. But in all of the cases, during the peaks of the revolutions, the internet was shut down for several days. And the movements and the revolutions even grew. And we have seen that in many cases. So 5 years later, there came also critical articles about that. However, internet shutdowns is not something which is not happening often. This is just a list of internet shutdowns from governments this year. And it's from several sources that we have collected that. And it was mainly happened because the government was facing opposition. An exception to that is for sure Ukraine, where it was introduced by Russia. But how to communicate then when there is no internet? This is our normal network structure that we usually have. Now, we have our device is connected to an ISP. The ISP is connected to a backbone and peering with some others. And then, so when we want to send to another computer a message, then it's usually kind of traveling this way to a server in the internet and then back, even when this person is sitting next to us. So we invented qaul to be able to communicate directly from end-to-end devices. And how can that happen? Well, we want to mesh them together just into one big mesh and enable over Wi-Fi and other means the communication. In 2012, we released our first version. And since then, we have gotten user feedback and also supported people in many, many countries, including Germany, Switzerland, Greece, Tunisia, Taiwan, India, Syria, Egypt, and Iran. We have rewritten the project on a completely new stack in the last 2 years. We want to be full stack, which means we support all the devices people usually use that they have at their hands. So it's not something for the server, it's really something for the end devices, which means we have a Linux client, we have an Android client, a Windows client, an iOS client, and a macOS client. We have 3 different modes of interconnection. Bluetooth Low Energy, we implemented that only by last week. A LAN mode where you are automatically found within a local area network with the other users when there is no client isolation, such as on this camp, unfortunately. And a static mode where you can statically interconnect yourself with some nodes. This can be a node kind of somewhere in this camp or in the internet. It just needs to be reachable, and when it's reachable, you are interconnected. And all those devices that are somehow interconnected are meshed together. In order to also make you as the user or another user aware of the situation, how you are interconnected. So of your own view, we built the network view that shows you that. And also all the users that are interconnected are automatically discovered and shown in your contact list. We have a shout-out mode, so you can just send a public message to everyone at this moment interconnected within the network. We, of course, have a private chat, which is, of course, fully end-to-end encrypted. We also have a group chat, which is also fully end-to-end encrypted, and you can add as many people as you like. We try to make the onboarding process as simple as possible. So there are basically two steps. The language selection, which is usually done automatically due to the language you have on your device. And then the entrance of a username, which can be any UTF string, even with spaces and so on. Because you are not identified within the network via your username, but via the hash of your public key, which is an ID and is used for routing and everything. So these are our features, and I would like to try a quick live test. Let's see what is happening. So here we already did the onboarding. Okay, so we have a bright mode and a dark mode, and unfortunately I have chosen the dark mode. So let's see whether we can change that. So we are here on the network view. You see how I am interconnected at this very moment. Of course, there is a settings page. We have here the language selection. It's really easy to add new languages at the moment. I don't know, we have over 10 different languages. You're very welcome to just add new ones. So the theme is just the default theme. I would say we switch to something more visible. Okay. Then we have here the shout-out mode, where we can just send a public note, which will, of course, not be encrypted, but it will be signed, so it's it is absolutely clear that it's coming from you. Let's send a quick hello. Let's have a look. Who else is here? Okay, Bob is here. Maybe we can start a chat with someone else. Alice is here. So here, when we go on the user profile of Alice, we see the identification, and we also see the public key. Now, we can just start a chat with Alice by sending to Alice a message. So now this message was sent to Alice, which is this smartphone I have over here, and Alice received it. And at this very moment that we did also the security, the crypto handshake, we call it zero-round encryption, which is maybe a bit misleading. It just means that the first message is already encrypted, but it's encrypted not symmetrically, but via your private key and the other one's public key. And then this is part of the noise handshake that we are doing, and afterwards you have your a static communication encryption key that you both share. And we see that this message has been arrived at Alice via this. So let's see here. I also have the possibility to, how do I do that? To take a selfie and send pictures from here to another device. They will just appear as any other chat message. Of course, you can also send files and so on. And when we have a look who else is here, for example, then we can see that Bob is interconnected with Alice. And this is done because Bob is another mobile which is interconnected over Bluetooth Low Energy with Alice. And for example, we can also create a new chat group to show this feature maybe quickly. So let's call it camp. I create it. I can select the users that I would like to invite into these chat groups. The users get sent an invitation. The invitation is shown, and they can accept it or, of course, deny it. And then we see that the people have joined the chat. So, what else? We also have an internet overlay, which means that you can have static nodes in the network, and you can add your own, and you can connect to them or disconnect to them. So all this kind of stuff. And what happens now if somebody is not online, which can happen really easily? For that, we have built a second level in our routing protocol, which is called delay-tolerant messaging. This means that when somebody is not available, you first check, is there some social distance or social proximity to another user? Let's say you are in the same chat group with other users. Then this user would most probably volunteer to transport this package, this message, which is fully encrypted. The user cannot read it, just knows to whom he needs to send it. And you can also manually say, okay, if the user is not available, I want to send it to this other user, and this other user will volunteer to carry the packages to the other person. I guess I ran through quite a lot, so let's jump back to the presentation. Maybe a very quick look into the technical setup of how we have done that. As we tried to be able to run on literally every device, we created a library in the background which is called libqaul. Libqaul is written in Rust. Under the hood, for some of our messaging, we are using Rustly peer-to-peer. This gives us already a trusted and transport encrypted connection. In that, we have user discovery, identity creation, the signing and the encryption of the transport, the management and storage. We added extra to that, the messaging, the group chat, the file sending, and so on. So, and for the interface, we have chosen another technology which is quite okay. It's Flutter, which is an open source project also that runs on all these 5 operating systems that we support. So it's for most of the things, it's write it once and it runs everywhere. Of course, there are always things that you need to tweak. Maybe a quick look into our future. We are shortly before the release of the qaul metrics bridge to interconnect qaul also with other messengers. We, of course, want to be able to run on OpenWRT. This is still to do. We are working and still are looking for more collaborators to find good ways to make user discoveries in really large wireless community mesh networks. Because what we usually use and what you usually use at home for user discovery is called MDNS. MDNS is fine if it's kind of a rather small network and to find your printer and so on, but it does not work well in large mesh networks. And then this is something we really want to solve, and which would be very usable for many peer-to-peer projects. We also want to extend our routing protocol to a multi-hop, multi-route, delay-tolerant networking. We want to have public file sharing, voice and video chat. So, are there questions? Thank you.
I think this one was first, then you, and the rest we see.
Thanks so much for the great presentation and for this awesome work. I'm just curious, how do you help ensure that people in countries that experience internet outages and still use this tool?
Can you repeat your question?
How do you engage communities in countries that are impacted by internet outages or internet shutdowns?
We are not engaging. They usually contact us. It's all published on GitHub. We are in some of the stores. You can download the apps. Usually then we get tickets on our GitHub. We get contacted by email and they ask questions. So it's the other way around. Yeah.
The others here.
Hi. Are you connected to the Pescucha store that's used in Iran and a few other places?
There are quite a few Iranians that send us a lot of great testing feedback and also pull requests. I don't know which group they do belong to.
Okay.
Okay, there's one over there.
Hi, thank you for the talk. Kind of interesting project from a resilience point of view, but as you mentioned Iran quite a lot, how do you actually prevent from someone in the network, especially from broadcasting, to just fingerprinting the users? Because fingerprinting those users is basically equally like fingerprinting potential protesters and bringing them into jail.
Yeah, that's true. And I guess this is also one of the points for which we have built qaul. We have built qaul for communication. If you don't want to communicate, if you don't want to be visible to the people next to you, don't use it. Use something else. So it's great to use it in situations where you want to communicate and you want to find other people and you want to be able just to kind of shout out something. I mean, finding out what somebody or in which way somebody is communicating is usually when you have a network overview possible. So when you are just locally, it already gets a bit more difficult because you need there to be in place. When you know or you expect that people can do that, then kind of you can reflect on it, what the risks are and whether you want to do that or not. But also one of the big problems we always see is that when the onboarding process is really complex, nobody is doing it. There are private messengers that kind of, it takes a while until you onboard, and we test it since quite a long time, and then people are not using it. So especially when you are also, it's not only for uprising, but also disaster recovery and so on. There, you don't have time. So you don't have the possibility. Maybe you have some structures, but when it's an entire population, then these structures that you maybe built may be very, very small and are not useful for larger communications. Do you have a follow-up?
You have 10 seconds.
Okay, thanks for the clarification. Just please make very, very clear on your website that it's not for privacy reasons. It's just to be able to communicate. Please.
I would not say it's not for privacy reasons, because everything is transport encrypted, everything is end-to-end encrypted, except what you do in public chats. And this is clearly noted. This is public. And with almost all the other messengers, even with the very private ones, you can, when you survey the network, see that this user was communicating, and even most probably to whom this user was communicating. So this is always a bit a chicken and egg problem.
Yeah, maybe going a little in the same direction. I was, if I got it right, the identifier for routing will always be a hash of the public key, right? And there are approaches like simplex where they use like temporary identifiers. Would that be possible in such a mesh setting to negotiate these? Because that would mean that every device in the network would have at least access to the metadata of who communicated to whom, right? So is that possible in a mesh setting, and is it on the roadmap to negotiate temporary identifiers?
No, this is not on our roadmap. It would, of course, be very interesting to think about that. But when you want to solve two things, which means direct communication and delay tolerance, you cannot change your identifier. Because when you change your identifier, you have no idea where the packet should go. Also, when you mesh and it has to travel, when you change the identifier, you have no idea where the things should go. So this is something which we kind of do not have on our scope. And yeah.
Okay, last question.
Hi. Have you had any problems with malicious users on the network, flooding the network, or basically clogging up the pipes between the devices, given the fact that you're storing forwarding devices? Because I've seen this quite a lot in Haggle, in content-centric networking, named data networking, that this is a problem.
This is actually something we have very high up in our to-do, to really do spam protection very well, to do blocking. We have the feature to block other users, so this is already the possibility to do. I guess as we only release this new version, which works quite different from the first that we have last September, and I would say it's now stable to use it. We did not have these problems yet, but they will come.
Okay, this we are out of time, unfortunately, but maybe a final word. Where can people find you if they want to keep chatting and exchange on the tool?
There is this website, qaul.net. On it is everything. There is the linked GitHub repository. We have a metrics discussion group. Yeah.
Okay, very good. Then thank Matthias again for his presentation.
You're welcome.